Hi there, can you hear me? Thanks for the mic check. I should probably play some music. Where is the music at? Oh, there we go. Hey, there's some music. Well, we'll see if this automatic redirect works or not. It's always dangerous when you use your own software. look at that. Okay, well, I have a feeling that we are working just fine. Hello, everybody, and welcome to, wait a sec, gotta get my coffee. Hello, everybody, and welcome to the live stream. On Friday morning, May 24th, 9 o'clock in the morning, I invited my Coursera students and all those folks. Here, let me move this somewhere else, so I don't have to watch myself talk a little bit late. And so, again, welcome to all my Coursera students. So the format of this generally is I talk for about maybe a half hour about some topic, kind of like my little every couple of weeks TED Talk. If I had a TED Talk every couple of weeks, maybe kind of like a podcast. And then at some point we switch to your questions and answers about Python, the Python course, the C course, Django course, online teaching in general, anything that people want to talk about. So I am going to go ahead and I am going to start my presentation. So let me set my cameras up for that. And there we go. Let's, I think that, yeah, maybe I will put myself in the lower right hand corner. So that is what you should be seeing. Yeah, okay, so that works. Okay, so there we go. So basically, I just finished this course, ccfree.com. It is on Coursera. It's getting some uptake. It's in some ways, it's my masterpiece. It took me 4 years to build this course. I started building the course before the pandemic. When I build courses, I start by building auto graders. This course had a special aspect to it because I needed to create a textbook. And I created a textbook by getting copies of this out-of-print 1978 book. I probably have about 100 copies of this now because I bought every used copy I could for like a year until I found a really perfect one. I cut the spine off and then I digitized it. And then I created the book that is now on CC Free. I had graduate students do typographical error checking on it, built unit tests for all the sample code, made sure that I could compile the sample code with a modern compiler. I have to put tons of compatibility options because the variant of C that is in 78 is not the same as the modern C. And so that took me a long time to build a book, to build a way to execute code in the browser, because I always want to make all the online courses that I create be exceedingly scalable. And to do so, I need to create, like, when students submit code to a system, you have to assume that that code is kind of attacking you, because you can't just take student code, run it on your computer, just drop it in, compile it, run it, because it could, format your hard drive or remove all your files or delete your database or something, right? So, and it's pretty easy. Easy is not the right word for it, but you just have to assume it's easy. You have to assume that, yeah, okay, yep. So people are seeing us on LinkedIn, so that's cool. Seeing us on YouTube. This is the first time I've figured out how to time it in such a way that I got it up on YouTube. And so you have to protect this stuff. And so building an auto grader and making it so students can execute code. It's so difficult for students to install a C compiler, install an editor. Now, if you already got that, that's great. But if you are a beginner, which I always sort of try to make my courses for everybody, it's really nice if I can give you a browser-based environment that allows you to do most of the work in the course, because then your installation and the tech support required for the installation of your stuff. So all I'm saying is that this was kind of a masterpiece for me. I've been building online courses for a long time, And there are so many things in this course that I have done the best I could possibly imagine doing. One of the things has to do with blind and low vision users' accessibility, which is in most courses an afterthought, kind of to protect from legal trouble. I have been thinking for almost a decade now about how to create materials that appeal to blind and low vision users, even on hey everybody coming in, that's cool, it's good to see you. I will talk to you in the chat in a little bit. And so I've tried to create, maybe I'll show you at some point some of my techniques for that would be another good TED talk, just talk about blind and low vision users and that kind of stuff, and how much that means to me and how much effort I put in. The simplest thing was I read the book. And not only did I read the book, because reading the book is kind of only half the battle, I also made sure that the book was in HTML pages. And blind and low vision users are really good at HTML, as long as you make the HTML accessible. And if you want a blind user can sort of zoom, page through a book really fast, right? If it's in HTML. And so that I wanted them to be able to move around, but again, the masterpiece. And so I spent so much time building this course. And the other thing that happened in this course is that, and if you go into it, you'll see I have these a poem from Robert Frost. And originally I decided that I was going to stop the course before chapter 6. And it had to do with the fact that I just thought I was teaching the C programming language, and I didn't want to teach complex data structures, because that turns out to be a rather computer sciencey topic. I didn't want to mention C++. I wanted to treat C as this really small, basic, close to the metal language. And I taught the course in winter 2023, so that'd be January through May 2023, to a small 15-student class at the University of Michigan. And I said, we're done now. And they're like, no, you're not. You got to talk about C++. You got to talk about objects. You got to talk about linked lists. And some of these students had taken a C or C++ class, and they liked it. And I thought, oh, that's too hard. And they're like, no, if you don't explain that stuff, you're doing your future students a disservice. So I scrambled and I redid a whole bunch of stuff. And I really, if you go on to Coursera, the 4th course is really something that was added because students who I exposed to the course insisted on it. And so I was like, go and make all this new stuff and remake lectures and do all this stuff. And when I was teaching chapter 6, and chapter 6 in this book is, chapter 6 in the book is called Structures, which is linked lists, pointers, all that stuff. Chapter 5 is pointers and arrays, and I was teaching that, but then I decided to teach chapter 6. So the problem is you got to figure out, I didn't just want to teach linked lists, which is in the book. I wanted to, so I'm like, oh, hey, look, Python has a list object and a dictionary object. And so, off I dive into a whole narrative of how to use linked lists to implement the Python list object, and how to use hash maps with buckets and chains, also known as the most popular code interview question in the universe, hash maps with buckets and chains. And I wanted to use that for dictionaries. And then I wanted to talk about abstraction. And then I brought C++ in and talked about how there's this concept, this abstraction of maps, key value pairs, and arrays/lists. And all that stuff, it's like all of a sudden I realized that, because the students were driving me in that direction, that I really was talking about object orientation. I was talking about the concept of an abstract interface and an implementation below that abstract interface. And if you look at my Django class and the Python class, teaching object-oriented programming is one of the hardest things that I find in all of teaching programming. And I'm like, oh wow, this course has turned out so cool because I've found a way to teach object-oriented programming. So if you take Python for Everybody, it kind of introduces self and object-oriented programming, and methods and attributes and terminology. And I consciously, in Python for Everybody, keep it really simple, knowing that we're going to come back. In Django for Everybody, we use a lot of objects, we do a lot of work, self is all over the place. I'm not sure students understand it as well as they should in Django for Everybody. And then here I am in C Programming for Everybody, and I felt like the explanation in the last part of C Programming for Everybody was just magnificent. I'm like, this is, if students can understand what I'm teaching here in the 4th course of C Programming for Everybody, they're going to understand objects like the rest of their lives, as well as some of the best and most experienced programmers. I think objects completely different than the way a student thinks objects. I think of objects as things that solve my problems, right? Ways that I solve my problems. So I built this class, finished it up. I was in a hurry to get it on Coursera, so fall 2023, 6 months ago now, 8 months ago, 10 months ago, 8 months ago. Fall 2023 at Michigan, we started the sprint to put it up on Coursera. And again, I'm sitting at the end of a 4-year effort. And I was all like blinders on. Let's finish this thing. Let's get it up. Let's get it on Coursera so that you students can see what I thought was the most beautiful course that I've ever produced. And so we finished. We finished the 15th of December, 2023. It went up on Coursera right on time. And that was holiday time. And so after I had 2 weeks to relax. Class was, I wasn't teaching. 2 weeks to relax. And I kind of started reflecting on what we had accomplished. And I'm like, whoa, I wonder if I inadvertently was unintentionally following the path that Guido van Rossum followed Christmas 1989 when he started writing Python. Python came out like early 1990, and he just kind of, like me, started a crazy idea over a holiday break. And I'm like, whoa, wouldn't it be so awesome if the code that I built in C Programming for Everybody was exactly the same as the code that Guido built? Okay? And so I'm like, I better answer this question. Now, there's a couple of ways I could have gone about answering the question. One of the ways I could have gone about answering the question was I could have looked at the source code to the dictionary and list implementations in GitHub, because all the Python code is in the implementation of Python, which of course is C. I could have read all that. I could have figured it all out. And I have looked at it from time to time, but it's big. It's a lot of code. And I was pretty confident that I knew what I would see if I looked at that code. And so I thought the more interesting question is to talk to Guido van Rossum about that, right? Hey, I went to the Python a couple weeks ago. Let me show you this. I don't know how well you can see it. This is my cardboard cutout of Guido van Rossum that I got at the Python conference. Like last week I was there. This was at auction. You'll see that it's signed by Guido van Rossum himself, front and back. And so I will put him back here. So Guido van Rossum is so he's back there. He's always present. He's sort of behind me, sneaking around, peeking over my shoulder while I'm doing live streams. So one of the things I want to do is I want to take Guido van Rossum's cutout. He might get mad at me for this, but I want to take Guido van Rossum's cutout like in my race car, on my boat, and when I start flying, I'll bring Guido van Rossum in the airplane, and he'll probably be mad because he's kind of a quiet reserved fellow, and so here I am like hauling him out in all kind of social media situations. So I thought to myself, I'll just ask Guido. I mean, because you've probably heard the story that like in February of 2023, I asked Brian Kernighan if I could go out to Princeton and film him, because I'm an amateur documentary filmmaker, right? And so I sent a note to Guido and asked him if I could come out and film him as we have a conversation about the internal implementations of list and dictionary in Python. And that visit to Guido's home in Northern California was quite surprising. And that's why I call this the plot twist at the end of the C Programming for Everybody movie. And eventually this will be on Free Code Camp, and it'll be like a movie. It'll be like 13 hours of stuff, and then there's going to be this plot twist at the end, an extra hour or so. And with that, let me switch to my screen and go through some of the PowerPoint from what I call the epilogue. So let me switch to the screen. So let me put myself back in here. So there we are. So this is the, if you go, let's let me get another screen here. If you go to www.cc4e.com, which has all this stuff, you can right this minute go into lessons and go into the epilogue. This material is not yet in the Coursera course. I've just met with the University of Michigan people to get this put in. And so, but this is all of it. There's like this welcome, this is the video for welcome. Then I have 2 interviews with Guido. One talking about like the internal object implementations inside Python for 20 minutes. And then we got talking about where his inspirations were. And I'll summarize a lot of this. I'm not going to show you all this. And there's just so let's see, it's 18 minutes. That's 30, 43, 54, 59, 69, 74, 11, 74 and 40 is 110, 130 minutes. So 130 minutes, which is about 2 hours. So this is like if you watch all this stuff, which you will on Free Code Camp, this will be like a 2-hour epilogue to an otherwise like 12, 14-hour movie that is all of this stuff. And it includes the reading. So if you go in here, you see the, well, that's the wrong one to look at. You actually see the readings of the book. And this is not just video. It's a YouTube video, but it's also an audio, and you can get this from a podcast. And I think that's audio.ccfree.com. Yep, there you go, audio.ccfree, and you subscribe to that on your podcast. And I thought, maybe you could learn C programming in your car listening to a podcast. Please drive safely, of course. Oh, so okay, so that's the book. But I've got this all set right now online, free, no cost, at ccfree.com. And so you can see it as much as you like. So it begins, and here's the PowerPoint, and this is the PowerPoint that I'm going to talk about right now. Okay, so I have this saying, and I just made this saying up, but it's a saying that means a lot to me, and that is, you think you're done with something, and C Programming for Everybody, I thought that I was done with it, several times. And then all of a sudden a surprise happens, whether it's my students telling me that I needed to cover linked lists in C++, or me realizing that maybe I should talk to Guido van Rossum about it. And so in the class, what I had done was I just was teaching this book, right? I was teaching this book. And I was just looking at this book like any teacher would, and just like, okay, how can I come up with something that explains this page? And then, how can I come up with something that explains this page? And on, and on, and on, right? And so I had this very heads down view. And I just have been a computer scientist, and all computer science curriculums have been affected by this book, whether they use this book or not. So all computer scientists always teach linked lists. And all computer scientists teach bucket hash maps with buckets and linked list chains. And again, this Kernighan and Ritchie chapter 6 was like our guide. It was our guide, And whether you're teaching, you could teach in a whole different language, but you're still going to teach the concepts the outline of the concepts from this book. And so this book was like the foundation upon which we built all of computer science. And so my theory was, so let's see, there's some pictures here, right? We built, and this is all in the class. I'm not going to go through it again, but we built a really cool extendable array. And the key thing is it uses realloc. And when you do dynamic memory in C, you do free, malloc and free. And most things that we computer scientists think about are malloc and free. Realloc is a rare thing, but when I was building this string, the string just kind of keeps growing, and why not use this thing that we rarely used in computer science called realloc, which says, hey, C and the operating system, you gave me some free memory, let's make it bigger. And it copies the part in, and so you kind of know it. And it's a really elegant concept. And so when I was in the course building the string, I didn't use a linked list to build a string. That would be crazy. So I did that. And then I built the Python list class. And here I just have like, ooh, it's a linked list. Why? Because I do linked lists in my sleep. It's like a thing we do in computer science is linked lists. We just do it. And it's, whenever I write this code, and I wrote this code so I could have sample code in the course, it takes me a while. Meaning that I've done this 100 times in the past 30 years. And I always can make it work. But these lines in the middle, these about self-head and connecting the new thing to the end of it, self-head, self-tail, and what order those three lines have to be in, I always figure it out, but I always have to draw a picture to figure out those three lines. And that's why it's so fun for computer science to teach linked lists, because you can it's like easy once you know it, and it's difficult until you do know it, and it's elegant once you see it. But it also, no matter how good you are, there's a certain difficulty in making it work. Okay, and so it's kind of like, it's that perfect blend of complexity and elegance and satisfaction when you know it. And I, every time I get my linked list working, I'm so satisfied. And so again, I just went through and thought, oh, that's how Python did it. And so of course, I'm mentioning this whole, adding a new thing to the end. That's the tricky part, and that's where this code is right now, but it probably wasn't right for the first 10 minutes I'm writing the code. And I'm like, oh wait, I got to do this thing in this different order, or blah, 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 blah. Self, tail, next equals new. What is that? Well, that's the old tail. The next equals the new thing I just added, right? Okay, so again, so we do a dictionary class. And that uses hashing. Of course, hashing takes a big string of data and moves it, does some kind of sort of recombinant algorithm, exclusive OR and shifting, and exclusive OR and shifting, and whatever, until you got something that can be moduloed down to some finite size thing. And so if you have a hash table with 16 entries in it, you modulo 16 and get a number from 0 through 15. But the data can be extremely large and scanned really fast with some kind of a recombinant numerical calculation that gets down to that. And then what we do in the classic Kernighan and Ritchie is we have in effect, however big our hash map is, that becomes a set of linked lists. So it's really quite simple to build this, especially if you just got done building a linked list. A hash map is really nothing more than multiple heads, multiple beginnings of linked lists. But once you start at the right head based on the key running through the hash, getting to the right bucket, it's a linked list traversal. And then there's little things about reallocating and making it bigger when the chains get too long. And again, what I'm talking about now is I'm talking about what they ask you to write on a whiteboard when they say, draw a picture of a hash. It's not the picture of the hash inside Python, as we're about to find out. And so, it's what it looks like because it's got multiple linked lists and there's next pointers and all that stuff. But again, once you get to the right head using the hash, it's really just a linked list problem. So this is where I decided I would go see Guido van Rossum and fly out to his home and take a copy of the Kernighan and Ritchie book. And it was kind of funny because because Guido and Guido apparently seemed like it was a fun thing to talk about. And I think not a lot of people are old enough. Everyone's just like, Python miracle, let me talk to you about how miraculous it is and how pandas works great. And I think he's sort of like, I don't think enough people care about the beginnings of it, because that's when it was him, right? And so he seemed to enjoy the idea that I was going to come out and talk to him about the first weeks, literally the first weeks of Python. And so what I did was I brought him a gift. I had taken copies of this book with me to Brian Kernighan's office at Princeton a year earlier, and I got a bunch of signed, I have like 5 signed copies. And again, that's out of print, you got to buy it used, etc., etc., etc. And so here I am, I hand it to Guido. And I say, Guido, turn to page whatever, chapter 6, and leaf through this book. Again, this is a situation where I did not understand, I did not know the answers to the questions I was about to ask him, right? I didn't understand it. And so I said to Guido, just skim through this. And he skimmed through for a while, flip, 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 flip. And then I said, do you recognize chapter 6? And he goes, well, I'm sure I've seen it at some point. We all saw it. We all used it. But I don't really recognize it. I said, did you use this book as like the blueprint for the data structures in the first iteration of Python? Did you use this book? Because I use this book to build my Python data structures. Because again, I'm a trained computer science with a PhD, and I've been taught and I just thought, of course you would. And the interesting thing is, no. I wouldn't say that Guido van Rossum doesn't like linked lists, but he might not like linked lists. He just thought in some ways, I'm kind of guessing and projecting a little bit, that Guido probably just thought linked lists were unnecessarily complicated. And part of that was because the thing that came before Python, and we always say ABC came before Python, right? Python, ABC didn't use linked lists. It uses a thing called B-trees, which is a very database concept. And he just looked at that and he said, what a complex mess. And so at some point I asked him, I said, of course you used linked lists for Python lists. And again, when you watch these videos, you will see that I am confused when I'm asking the questions. Usually I'm often confused. Like when I was talking to Brian Kernighan in early 2023, I was confused in that interview too, and he would keep correcting me. But I just cut out all the parts where I was confused. But the Guido interview, I didn't cut all the parts. I was very confused. I really was very confused as we were talking. And I didn't cut all the confusion out. So I'm like, you didn't use linked lists. I'm like, what did you use? And so he uses arrays. I'm like, arrays? Why would anybody do that? And again, I'm confused during the interview. And it wasn't. He didn't like linked lists. He didn't like linked structures. And so he said, it's just an array of pointers that I realloc, which is kind of like what I did when I built in the class. I built the string class. I realloced it. I just made an array of characters, and then when it got too big, I realloced. He said, that's what I did for list. And I'm like, oh man, that's so not computer science. You're not doing what we computer scientists would have taught you to do if you really studied well in a data structures and algorithms class. Of course you'd written a linked list, because it's what we do. And then I asked him, I said, okay, after we talk about linked lists, it's a 20-minute interview, and you can watch it at your own time. And then he said, and I said, okay, great, you don't use linked lists, but you use arrays instead. Got to drink some more coffee. I said, well, please tell me that at least hash maps use buckets and linked lists from buckets. And he said, kind of like, Chuck, you did not hear what I said. I don't like linked lists. And I said, oh, how can you do a dictionary without hash maps and linked lists and buckets? And he goes, well, I use an array of pointers. And I'm like, okay, explain to me how that works. So it turns out he had taken a different book. This book is Knuth Volume 3, Sorting and Searching. This is a much earlier book. This is like a early 70s book. Donald Knuth was like the algorithms god. And everybody there's three volumes of this, Volume 1, Volume 2, and Volume 3. And I don't know if you can see this, but it is really very, very explicit. He would create algorithms, and he would show them to you in this very assembly language-like way, which meant that we as software developers he broke it down to the simplest thing, like how a machine would actually do it. And so here on page 514, there's some more code from the Knuth book right there. That's his way of showing us an algorithm, because you can't, it's a little longer and more complex, but you can't get it wrong. I mean, if he can show it to you in machine language or assembly language, you can't get it wrong. And then he has all the math and stuff to prove it's a good idea, which I don't care. And so Guido found this thing called open hashing with linear probing in this book, and he read all this stuff, and he goes, oh, that's a great way to build dictionaries, right? And so he made open hashing. And so then what I do in the class, in the epilogue, is I go and re-implement the Python linked list the way Python 0.9 did it back in late 89. And so what he did was he just made an array of pointers. And you can watch this whole thing. I'm not here to do this whole lecture over and over and over again. It took me 2 hours to do it at the fastest pace I could. But basically, it's just an array of pointers, and they are extended. When you run out of space, you just reallocate and make it bigger and have more pointers. And if you think about it, and you look at the code here, you're like, that is simpler than a linked list. And the reason why we software developers and computer scientists software developers, we never trusted the reallocate code. And part of the reason is that we knew as how hard reallocate was. Reallocate is a hard problem. Java has this concept called garbage collection, and it's been 20 plus years that garbage collection in Java has been its Achilles heel. And so, but we knew that, and if you look in the Carnegie and Ritchie book, they even talk about how hard memory allocation is and reallocation. And so for me, as a computer scientist, my theory is don't use reallocate. And if you use linked lists or hash maps with chains, you tend not to reallocate anything, hardly ever. So you're mostly creating dynamic memory and then giving it back and then getting more and giving it back, but not using reallocate. But that's kind of a fallacy. I mean, eventually Guido told me that they depended so much on reallocate and they were disappointed, at least 10 years later, where Python was starting to be real and needed to perform better. They just cut out reallocate and they did their own reallocate, and they did their own garbage collection and all that stuff. And the reason is that Python itself could manage its memory better than C could. C is managing at a much lower level for many different applications, Python only being one of them. Why not create a memory allocator and garbage collector that is unique to Python? And so this notion that reallocate would be used for lists as they grew, they could start really small and they'd reallocate up. And then dictionaries could also start small and reallocate up. And so it's kind of a pretty thing. And so you can look here in the upper left, you see the linked list structure and the amount of sort of like extra crud that's in that. And then you just see the really elegant structure that is really Python 0.9. It just is an array. And the code, while the code is not particularly trivial looking, the essential part is just you have a pointer to you have the size of the allocated bit, and then you add one to it and put a pointer in. It's like, in some ways, I can look at this code, and it's not much shorter, but I can validate that I got it right. Meaning that my time from the time I start writing this code to the time I believe it's correct is much shorter than the same code that I would write with a linked list. And I'm familiar with both techniques. It's just linked lists just kind of require, a bit more effort, right? So, and then I go through his Python 1.0 dictionary from the Donald Knuth sorting and searching, and then I drew this thing. It uses this the conflict resolution is when a hash value has a collision, because it's starting with a big amount of data to a small number within a very specific range. Collisions are inevitable, so you have to have collision resolution. And the Knuth book does a reverse circular search, so it goes from where it should be. If that's full, it just works its way up, and then it goes down to the bottom and works its way up. It turned out that was easier for Knuth to write the loop. For us, the way we would tend to write the loop is to go down and then go back up to the top using a modulo operator, but Knuth did it differently. So if you're reading the Knuth book, you see that it's a reverse circular search, whereas the code I'm going to write is a forward circular search. And so basically, if you look at it, it's an array of key value pairs, and the dictionary itself is an array of structs, not just an array of pointers. A list is an array of pointers. This is not an array of pointers to structs, but an array of structs with key and value, and the key is a pointer and the value is a pointer. And I just made it string. Some of my code does like integer to string or a string to integer, but you can see the key value, and then when it fills up above some size, you got to reallocate, and I go through all that, and then all of a sudden you got a bigger one, and you got to copy all the things into it, and then you've copied these things. You don't reallocate the actual objects. You're really just reading the pointer values, copying them in, and then you get rid of the 2-size dictionary and go to a 4-size dictionary with a load factor of 50%, and then you can insert some more stuff. Now there's no chains in here, right? You have to reallocate the whole dictionary and make it big, and then you can't just do you can't just copy the stuff because of the conflict resolution, so you actually just have to reinsert them, and I have all the code for that. It's not that hard, and I walk through all that code in the lectures. And then we add some more stuff. And then I asked him at the very end, I said about the Python 3.7 order dictionary, and that's really beautiful, where it's in insert order, not sorted order. So there's no interest in sorting it, although some data structures in C++ and Java can have like a tree map which sorts by keys and stays sorted by keys, and we actually cover that in the C programming for everybody, but it ends up being it's probably the most complex part of C programming for everybody. But all he did was the key value pairs are now a linear list, and so I'm not sure that shares code, but it's a list of key value pairs, which is indexable by it's an array, so 0, 1, 2, 3, and the hash part is just a separate little data structure that is an array of integers, because this integer is the position within the key value array. And it turned out that because of the way hashes work efficiently, you can't really get above a load factor of 70% full and maintain efficiency. Whereas in the Python 3.7 and later dictionary, you can get 100% of this array at max efficiency, and the way I built it, I made this index array twice as big as the data array, and so I never get a load factor of above 50%. The reallocation is really simple because you don't touch any of the data, right, that's in the key value pairs. You just make the index bigger. You extend the list as a list of key value pairs a bit, and so there's this beautiful symmetry between the Python 3.7 dictionary and the Python 0.9 list. And so that was the first part of it. And so, of course, there is always more, my Steve Jobs moment. And that is, he and I, after I kind of understood everything I just told you about, started talking about his inspiration. And I always love this chalk diagram that I stole from School of Rock, where I show what influenced what. That's what I'm showing on this diagram. And what you mostly have seen is me talking about where the C language fit and how C influenced. Like C, the moment C was created, whether it's 78 or 87, 72, C changed a lot of things. And so that's what this picture is. And again, that's because C Programming for Everybody is a C class. But then we really started talking, and a new picture started appearing in my mind, because now I'm talking to Guido. So my C class is becoming a Python class. It all comes back to Python. And so I'm like, okay, so let's change this, and let's look at all the influences that led to Python. Not look at the things that C influenced, but instead look at things that Python were influenced by. And the coolest part about this is the modula influence. And then I was talking to one of my teaching assistants, and he said, yeah, Smalltalk has that too, the self concept. I'm like, where did that self come from? Well, Guido saw it from modula, which he met some people at a DEC research center. But then if you do some research into modula, and the problem was I didn't even think modula. I used Pascal, and I thought modula was kind of, by the time modula 76 came out, C was out, and we just weren't looking to ETH in Switzerland for the future. But modula was a great step beyond Pascal, and then modula 3, which was an object-oriented step beyond Pascal. But modula 3 was also influenced by Smalltalk, which was influenced by Simula. And so Python, again, he's European. Guido lives in the Netherlands. Modula, I think, might have been from Italy at a research center. And so, he saw things in the mid-'80s that I didn't see. And so the whole concept of self, he said, was taken from modula. And so it's quite beautiful to see how thoroughly he looked to every other project, evaluated every other project. He was like trying to create the greatest thing ever, and he was doing that by learning as much as he could by every other language that he could touch. So that's pretty cool. He also wrote some code in C++. I think that at some point in his mind early, he thought, oh, C++ will have so many cool features that it'll make writing Python easier, and it didn't. C++ is not sort of a layer that simplifies and beautifies C. It is a much more powerful tool than C, and it kind of gets in your way. But if you want its power, there's nothing like it. And so he did some work in C++, kind of prototyping work, and then he learned about C++ and was inspired by C++. And so C++ was definitely an influence. I think it was so much that he thought he might use it, but I think he gave up on it when he couldn't accomplish what he wanted with C++ and realized, I just got to go one layer lower and just do the hard work. And that was a great choice, right, to choose C as the language. ABC, one of the things that this thing taught me to do is to look a little more at ABC, and ABC was a pretty cool programming language. And so you see, if you look at ABC, you realize that there was a lot of things like split, trim, in, for, for in. You see Guido like really inspired by the programming language, the end user view of it, and it's really it's kind of pretty. And so he was the inspired by ABC is way more than what that sounds like on the surface, right? So he didn't like the B tree structure, which is a very linked. It's like B trees make linked lists seem simple, but they're all pointer based structure things, and then modula 3, like I said, had the concept of self. And so the last thing is my interview with Guido, the second half of the interview with Guido, where he talks about object orientation. And I let him finish the course. I let him finish the course. He gets the last word in my C programming course, ironically, and this epilogue really completes the transition of what I set out to be a C course to it becoming a Python course. And so I love how it turned out. I hope that a whole bunch of students take Python and then they want to be a better programmer and they take C right away. And instead of saying C is the language to learn data structures, I want to say C is the language to understand Python and understand Python deeply. So that is the end of my prepared remarks. Let me get this chat separated out. Get the dashboard. Let's see how I got this. Where's the chat? Where's the chat? Get this chat so I can start talking to you. So you can queue up some questions. Pop-out chat. That's what I want to do. Here we go. Pop-out chat. Make it bigger. So let me get in the chat. Actually, I can probably take that over. I can take it over. Well, I'll look at it. This way I'm looking at it. So, hi all. Switching to the live interactive part of the presentation. Please feel free to ask questiones in the chat. No question. Let me make this a little bigger. Well, Zach, thank you for the comment. Thank you for. Oh, so Zach's question is no question. Just thank you for Python class on Coursera. I've been studying it for about a year. In that is a really interesting topic that I think about a lot, and that is that. Hey, wait a sec. What happens if I do this? What do I see? Oh, no, that's not what I want. Can I switch it? Never mind. Okay. So, Zach says he's been studying for a year. One of the things I love about teaching on Coursera, that is probably the biggest problem with teaching live and face-to-face, is that when I'm teaching a 15-week semester course at the University of Michigan, I am making really hard choices. I have all these topics. I always have more than will fit in 15 weeks. And so I just say, okay, my on-campus students, I'm taking it out. So what you see in my Coursera classes is way more than, not way more, like 25% more than what I teach to the on-campus folks. But I have the luxury in Coursera of just giving you what I think is the right combination of things, not the combination of things that fit into 15 weeks with time for a welcome class, 2 exams, a final exam, yada yada, that eat up all that time. And so, Zach, what I would tell you is embrace taking a long time. And when you go from Python to C, you're going to take a long time. But I think it's important to enjoy that. I mean, live your life, do your job, make money. You might even be going to school for something else that's going to keep your attention. I'd much rather you took a longer time to finish the class than rush through it just to get a certificate and then forget all about it. There are many things in this world that you can rush through and accomplish everything and forget about it. So Natek asks the question of what is the future for C? And I think that C, I think that the average programmer, I'll say that if I look at a pie chart of all the programmers in the universe, I think that computer scientists should be like 5 to 8% of all software developers, no more. And I think that computer science should teach C, because there are so many things like Linux, the TCP/IP stack, Python itself, web browsers sometimes, web. They're going to be written in C for a long time. Like, it's unlikely that Python will stop being written in C. Although there are versions of Python written in other languages, the problem is that if you write Python in Python, then you have to have Python to create the Python. And so one of the weird things that we were doing is trying to find a modular compiler. And the source code for all the modular compilers is available, but you'll never guess what it's written in. It's written in modular. And so the problem is you can't make a modular compiler unless you have a modular compiler. And what happened was like modula 0.01 was written in something else, and then that was enough to compile a very early version of modula, and then you would start writing the modular compiler in modula and compile it, but eventually had a modular compiler, and then you would add features to it, and you have this stepping stone of compilers. And so if we were to switch to writing Python in Python, we might find ourselves 10 years later with, if we don't have a Python compiler, we can't make a Python compiler. Because that's what happens in modular. We could not figure out for the life of us how to make a modular compiler without unwinding 10 years of work before GitHub. So where is the first modular compiler? Compile a second modular compiler, and then make a compiler compile a third modular compiler, on and on and on. And so that's where the future of C is. C is a language that we will always have a compiler for. And so if you want to build something like a low-level library routine like TCP/IP, it's safer to build that in C, even though it's dangerous to build it in C. And one of the things you may or may not have heard of was that the U.S. White House, in a strange expression of something technically coherent, which surprised the heck out of me. Not that they're wrong, but they're not really good technical, right? I never expect that. They basically said that people should start using what's called memory-safe languages. And that is languages that don't, if you over-reference an array, it doesn't become a security hole in the system. And so they came up with a list of languages that they thought that people should be encouraged to write new software in. And those languages are, the key thing is if you over-reference an array, you get a traceback versus just blowing up. And the problem with over-referencing an array in C is sometimes it works, sometimes it blows up. And the times it doesn't blow up, it becomes a security hole. So C was not on the list of memory-safe languages. C++ was not on the list of the memory-safe languages. Python is on the list of memory-safe languages. So in terms of the future of C, while our low-level stuff is written in it, because it has to be, and historically it has been, and that will require, really great programmers to go work on Linux. You have to be a great programmer, because you're working in a programming language, C, that is so dangerous that you can get completely in trouble. So I want you to know C, but I don't want you to write C unless you're going to be really serious and really well trained and work in an environment where there's a lot of code review, et cetera, et cetera, et cetera. And so so the future of C is, it's our way of learning how computers work. And it's our way of becoming better Python programmers, not to become C programmers, so to become better Python programmers. And that leads to master programmer, which I'll come back to. Let's see what else we've got. I got Anna, how would AI change programming? I can talk forever about that. Word 2, how does one go about taking the path to becoming a master programmer from Python to C to Django SQL to get practical experience? Do you think learning about Rust is important to learning about C? You said at the beginning of the course, this course is not aiming but teach important topics. Hey, Stephen, I see you're here with a change in language. C is a big user and still, yeah, exactly. Okay, wow, there's so many good questions. Future of online learning. Oh man, Jaden. Well, I was wondering if I'd have enough questions to last a whole hour, because I got another hour scheduled for this. And right now on the screen, there are enough questions that go an hour. Holy crap, Daniel Garcia. I started role in QA and switched to developing, and that's why I started your C course. However, it's difficult when you don't have the free time that a student would have. What advice would you give me? So Daniel, the thing that I love is I love everything about what you just said. That you went to a technical place, you didn't have the skills, and you worked in QA, and then you started itching to kind of go beyond QA. I think the QA is one of the best ways to get into an organization. I've got a son, I don't know if he's watching now, but he thinks somehow, that doing QA or working in the call center, if you're working at the place you want to work, you might as well do QA or work in a call center. Because you got to understand, you can't go be a software developer without understanding the product of the company. So QA or even call center is a great way as long as it's in the right company. So it sounds like you're trying to switch to programmer and take the C course. So my suggestion to you, Daniel, and I don't quite know why you're not already doing this, so you can clarify in the chat if you want. I would hope that you would get to the point in your job in QA where you're making some decent money. You're getting so good at QA that you can work your 40 hours and then you have some free time. And so yes, you have a job and it's a full-time job, but my goal is to get you so good at QA that you not only have time, but have brain space. And so for me, the problem is more brain space. Because if you're still, like you just got hired at a job and you're working on QA and you've only been there 2 weeks, your brain is focused on learning whatever it is to be successful in QA. It'd be my hope that after 3 to 4 months, you'd be good at QA, and that would make it easier because a lot of QA stuff is somewhat repetitive and it's not like difficult. And that's what I crave, is when your brain has got some let's go learn something new. And that's when you take C and you don't rush. Just don't go any faster until you absolutely master, right? And hopefully your QA job is paying the bills and you're living your life, going on vacations, but your brain has got spare power and spare cycles, and that's what I want to fill up with, like the C course. And so as long as you're gainfully employed, and as long as you're paying your bills, and as long as you're kind of happy with your life, I think you should take a slow path to learning, which is the exact opposite of going to college in 15 weeks. So you say, I don't have the free time a student would have. You would be surprised how little free time students really have. Now, when they're on social media, they're having a good time because it's a Saturday and they're watching a football game. But the rest of the week, the life of a student at the University of Michigan, I am not jealous. It's fun to be young. It's fun to have fun on Fridays and Saturdays, no question. But the rest of their life is extremely pressure-filled. And in some ways, if you're working QA at a company that you like, your life is less pressure-filled than a student. And so I think more people take Coursera courses long after their education, because you can go slow in a Coursera course and hear this on-campus teachers like, next Friday I want these 4 things done or I'm going to flunk you from this class. And they're like, ah! And then they can't relax enough to take a C class that I'm teaching. They're like, okay, I'll get back to that after the semester, or I'll wait until Christmas break and learn it there. And then, of course, the thing they got to do in Christmas break is sleep and catch up on their sleep. So my advice to give you, Daniel, and feel free to send me something as you go through this, the path you're taking of having a cool job and getting so good at that cool job that you have time to work is a great path. So let's go to Ken. Do you think that learning about Rust is as important as learning C? As you said at the beginning of the course, that this course is not aiming to teach you how to write C, but teaching important topics. So I don't think that I will be doing a Rust course for a long time. And the reason is the courses that I want to teach you are courses that make it so you can learn Rust quickly from somebody else. I am going through an exercise. And for those of you who didn't see my, let me see if I can find it over here. kept editing these slides that I did in. Yeah, let me go to this one. Let me switch to this and this. Yeah, there we are. This is my master programmer talk. And so the problem is that in the working world, there are probably 30 to 100 different tech things that you're going to need. And we could say, well, why don't I just teach a class in every one of these things? And the answer is I can't. I can't teach a class. And the YouTube can teach you all this stuff. So you can go find a Rust class on YouTube. So I want to go through for the stuff that I'm going to teach, because I spent 4 years building one class. So I'm going to pick something that I think is going to multiply your abilities. And so what I did was I went through and I asked myself the question, like, of all these things, these are all good, are there 4 things that are more essential than the others and enable people with those? If you master those 4 things, the rest of the things become easier. Meaning, I'm going to teach you the 4 things, and I want you to learn the other stuff on your own. And so, Python, of course, C, assembly and architecture, and SQL. Now I have already 3 of these classes. Got a Python class, got a C class, I got an SQL class, and the next class I'm working on is computer architecture and assembly language. And that's because I want you to go deeper before you go higher. And so that's to me, if I'll only get you to take 4 classes and master those 4 classes, then you could learn the other things above, because you're smart enough to learn them fast and learn them well. And Rust is still in the above the line. And then I said, okay, when I'm done with the architecture and assembly language class, are there a few more things that I should be teaching you, right? As like such a profound basic skill that literally everybody needs to know it. Is everyone need to learn Rust? I don't know. And so what I came up with is, obviously we need to learn HTML. It's not going away. JavaScript is important, not going away. And then Java was kind of like the last one I added. You could literally make that last one be R. You could make it be C#. You can make it be lots of things, right? And so I just picked Java because it's open source and it's free, and I lean in that direction. But I don't think that Java is the only thing, but Java is the thing I'm going to teach, because C# is not used in open source. I'm an open source person. But that could be Rust in a few years. And so in this second layer, I'm not so like locked. Like if you'd asked me 2 years ago, is JavaScript in the second layer? I'm like, no, JavaScript is just a wreck. But JavaScript is getting prettier. And so by the time I'm done with the computer architecture class and I start teaching a JavaScript class, it's actually, JavaScript is getting better. That's a whole different topic about why JavaScript is getting to be a better language. And it really has to do with the fact that JavaScript has been so bad for so long that we've been forced to invent things like React to make it better. I think React's a fine thing to learn, and you can make a lot of money with React. But sort of as I look as a pure thing, would I teach React in a computer science degree? I have not looked into Zig, but Zig could be in the above the line. It's not gonna make below the line. If you look at everything I've got here on this below the line, they're all 20 years old or more. I will teach courses that last 20 years. I don't like revising them. Like the Django class I've got. Every summer I got to revise the dang thing because Django releases a new release and they break everything. Like PHP, I got to go back and do my PHP class. So yeah. So Rust, maybe. Rust might replace Java in this if it gets a little more popular, a lot more popular. Because Java, to me, if you like look at what people are Googling, they Google Rust all the time. But Java is the thing that runs the industry, not Rust. And Rust has potential, and we'll just have to see, right? And again, in my curriculum, that last thing I teach, which is Java in my curriculum, that could be replaced by any sort of capstone summative. That whole idea of that seventh course that's the course that overlaps with what you're going to do at your job. So Go, again, same thing. I think if you know Java, JavaScript, Python, C, architecture, assembly language, SQL, I think Go's easy at that point. So, yeah. Okay, so let me go find another. Let me go back and find another question. Amir, do any of your courses teach data structures and algorithms? They all do. Probably the best course that I've got right now for data structures and algorithms. I would say data structures, algorithms, and object orientation is C programming for everybody. When you get into that, you will realize that it is a long thing. You're writing a lot of sort of data structures, more than algorithms. And so, like, there are algorithms like, how to traverse a graph, or, this, that, and the other thing, and how a binary tree is better than a B tree, and a binary tree are better in certain situations. I don't teach a class like that. Like, what's the best sorting algorithm? I don't teach a class like that. And I just think that the average programmer doesn't need to know all that stuff. I think that that's fine for computer science. I'm not trying to be the best computer science class or curriculum. I'm trying to be the best programming curriculum. Yeah, Stephen, I'll vote for Fortran too. Fortran always makes an appearance in everything I do. So will there be a future course, Daniel? Yes, there future Java course. Yes, there will. But by the time I'm teaching Java, I'm going to be teaching applied Java. And so, like JavaScript and HTML, Python, C architecture, I'm going to teach those kind of like, here's a thing. But in Java, I want to switch to, because Java is capable of being used in large projects, I want to show you how Java works in a large project. So the Java class will really be two parts. Like, here's Java, quick syntax, boom, 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 boom. Uses semicolons. Here's your 2 for loops. This one looks like Python, and this for loop looks like C. So you see how that works? But you know Python and you know C, so I can teach Java really fast. And then I can talk about object orientation really fast, because you learned object orientation in things like C and Python. And so I can teach you Java really fast and reach strong understanding of Java very quickly, as long as you retain the Python and the C. And so then I want to get to the applications of Java, and that's where, like, the object orientation that you learn in Python and the Python and C courses will pay off, because we are going to use object orientation like a very powerful and sharp tool in Java. And you can't walk into that class and go like, oh yeah, object orientation, I don't really know. I know some words, but I have no idea. No, by the time you get to Java, you need to be whoosh, whoosh. Does it work? Oh, my battery's dead. Has this one got a better battery? Where's the other one? I gotta charge it up. Dang it. Gotta charge it up, sorry. I'll charge it up for a while. I should keep these charged up. I hope it's charging.
Not charging.
It's charging. Okay. So that one's charging. So what I'm saying is, by the time you get to the Java class, you need to be able to wield object-oriented programming like a sharp and powerful tool. And so you are learning object orientation in Python and C. Love it at the moment you're learning it, because it will pay off. It'll pay off in Go. It'll pay off in Scala. It'll pay off in Rust. It is going to pay off in C++. And the Python and C together least C programming for everybody, the way I teach it, that is what makes you a wizard at object-oriented programming. Okay, put that away. Note to self, whenever giving online seminars, always have a lightsaber charged and available. Camberto, do you recommend learning programming first before learning about data science and AI? Yes, I think it's a necessary prerequisite. I mean, if it were me, I'd love to see you take the Python course and the C course, because if you start doing things in data science like NumPy and Pandas, it helps you so much if you have an understanding of what's really going on inside a computer. And whether you think a NumPy, when your NumPy says, I just ran out of memory, what does even that mean? But if you take the Python and C class, then you'll be like, oh, wait a sec, I see what I did there. And I asked NumPy to do something that just was like an infinite combinatoric thing. And yes, it was easy for me to express it, but then it was very confusing and ran out of memory in the middle. So, so there's another question about, there's a lot of videos that compare object-oriented programming and functional programming and choose one over the other. Most of it's talking about object-oriented programming. Do you think that learning a functional programming language is any better? That's a really tough question. So I think of sort of procedural, object-oriented, and functional as kind of like a sliding scale. There's no such thing as like this is object-oriented programming. Because if you look at Java, Java has like functional aspects. Python has function. Python's a very procedural language. It's also an object-oriented language. And with lambdas, it's got functional stuff. And if you start looking at things like NumPy and Pandas, is kind of functional. My favorite functional programming language is one of my favorite languages, and that's SQL, because you're expressing what you want rather than how to accomplish it. And so I just see functional as two sides of the same coin. I don't see them as like one replaces the other and like functional is good and object-oriented is bad and procedural is bad. No. Procedural, object-oriented, and functional are just tools. I will say this. Functional programming is hard to, in my opinion, to make natural. So we're seeing things like lambdas, and there's things like streams in Java that are very functional programming inspired. And the problem is functional programming, you say, I want this, and it's supposed to create this pipeline of data, and then like a little perfect thing drops out the bottom of that. And the problem is that if you're doing data science and you create a pipeline that does a complex thing, and you slowly but surely debug this kind of very high level pipeline, an SQL statement is similar, and you get it right. So debugging a single statement of SQL can take hours, and debugging a NumPy or Pandas pipeline can take hours. But then once you've got it, it's a very beautiful expression. You might even have to optimize that pipeline. You're like, oh, this is the way I expressed it before, but that caused too much memory to get used. So I'm going to change that and do this other thing, put them in a different order. And so functional programming is great, unless what you are doing, to me, and this I see in the Sakai project, everybody wants to do functional programming so they don't have to write for loops. It worries me when you're building something that's kind of a low-level tool that has really strict performance and memory concerns. I worry that if you write everything in functional programming, and the functional programming is not implemented well enough, then you end up wasting CPU or memory or network bandwidth or file bandwidth because you wrote this thing in such a generic way. And if you take the Postgres class, I talk about how when I saw my first join, I thought about how a join had a combinatoric explosion. And I'm like, I'll never use a join. Join is the dumbest thing, because if you take everything in this table, connect it to everything in this table, that's too big. Especially if you do 3 tables, then it's like infinitely big. It can't work. Of course, that's not how join works. But it took decades to get join to be so fast that we can express a join, which is expressed in a way that feels very explosive from a combinatorics perspective, but yet it's not. Somebody worked really hard to make that functional programming more efficient. And literally, a join is more efficient than any code we could ever write that's non-functional. And so that's when functional programming wins. But if you're writing Linux and you're in the middle of something, functional programming is dangerous because it's got to be tuned. And so I see functional things coming into Python. I see functional things coming into Java. And I think that just doing functional programming is easy when you're writing a hello world application or a one-time pipeline that you're exploring some data. Because then if it blows up and runs out of memory, you're just like, I'll do something different. Whereas if you're building an operating system like Linux that has to work for the next 20 years and not have security holes, a lot of functional code inside Linux doesn't make any sense. So all I'm saying is functional is just a style of writing stuff, and it seems very easy to express, but then it requires a little more expertise and analysis. And that's why you should take a C class. So functional, not bad, but it's not sort of just a panacea replacement. SQL is functional, and I love it. So let's see where we at. Yeah. Python can get you started. You don't have to really understand the low-level stuff. But if you're going to be a programmer, you want to understand the low-level stuff. Okay, let's go to Jaden. Still got 45 minutes. I hope I don't run out of coffee. So Jaden asks, "Hi, Dr. Chuck. Hope you're doing well. I am doing well. Summer's here. I'm almost caught up with stuff so I can start writing code and fixing some guy bugs, which is what makes my summers fun. I've been loving your Python for Everybody course on Coursera. What are your thoughts on the future of online learning, and will you create more classes in the future?" So my thoughts on online learning are pretty deep. I've been thinking about online learning. I've been doing online learning. I was one of the first people in the world to do online video streaming in 1997. Back when we had modems, regular dial-up modems. And so I've been doing online learning, so I think about it all the time. And what has been in my mind in the last few years, like Coursera is 10 years old now. And Coursera hit at a moment, it was exactly the right thing. They're a multi-billion-dollar company right now because they just stumbled into a really good idea. And it was a really good idea. And what I've had the luxury of doing is to be a teacher at a world-class university, University of Michigan, and be part of a world-class online scalable education system, Coursera. And I've been able to compare and contrast what each of them do well and what each of them do badly. And I'm not worried about the future of higher education. I'm not worried about the University of Michigan running out of students, especially at the undergraduate level. But I am beginning to worry about the premium that we can charge at places like the University of Michigan for master's students, and in particular international master's students. And I think that somehow that cost, where we're making so much money on international students, that won't be the same in 10 years. That won't be the same in 10 years. I think what's got to happen is there's got to be a way to take the kind of amazing and deep skills that we give to people in a on-campus master's degree, and we got to give those same skills to people at a distance. And we got degrees on Coursera, and they're expensive, and they have problems scaling. They're costly to produce, and they're costly to take. But I just think at some point we've got to solve those problems. We've got to create courses that scale to tens, if not hundreds of thousands of students, but accomplish what it is we accomplish with an on-campus education. And that is like transform people's lives. Have them ready to do things that they couldn't do before they took the class, and that they can't do by just watching a bunch of YouTube tutorials. YouTube tutorials have a really short retention time, and they're great when you want to say, like, how do I make a socket connection from Rust? YouTube tutorial, some code goes in. That's not how you create retained knowledge. You create retained knowledge with a constructed curriculum where the pieces amplify each other and build on each other and amplify each other to the point where you're creating sort of a completely connected mass of knowledge inside of a student's mind that then they can use to kind of add to. And so to me, the future of online education is better education, less cost, location is irrelevant, and people can do a purely online educational activity and be employed as a result of that. Because I don't think we've done a great job. We have done a fine job of giving people, like, learn Python, go get a different job. Learn C, move from QA to developer. So those are things that are like little tiny strategic small puzzle pieces. But I don't think we've accomplished enough online for the whole puzzle. And that is, you're 17 years old, you're coming out of high school, and between 17 and 23 or 22, you're going to have this condensed learning experience, and you're going to have materially, not just had a few new skills, but materially changed. So I think we got to find a way to do that online. And I think about that all the time. The Path to the Master Programmer is, a prototype of a complete education at a distance, a complete job-ready education at a distance. And again, the key to making that is it's got to be a multi-course curriculum that has been constructed to achieve a goal, which is what we do in on-campus education. We have many courses, we construct them together, and we're trying to achieve a goal. And so I think that we come back here in 10 years and we'll see things that are beyond Coursera. There will be something that is even more relevant than Coursera. Coursera is great. I got no problem with it, and it's the best we've got. And but I see so much more potential for educating people around the world from a place like University of Michigan in a way that gives you a great education and prepares you for work, and maybe even has a student services and job assistance and interview assistance and alumni networks and all those things for a University of Michigan worldwide education with 100,000 alumni that identify themselves as University of Michigan alumni. That's my theory. That we're mostly online. And then, once I do that, then I want to make it so that people come and visit, and instead of coming to the United States to do your education, you can do your Michigan education anywhere in the world, and then you come to the United States to visit and hang out and just spend a month or two, and then go back to your country and live your life and be with your family and eat good food. And it really bothers me that people can't just come to the United States from a lot of countries for a month and enjoy the United States and share what our culture is with all those people. And then they can go. I mean, I'm blessed that I can jump in a plane and go to lots of countries for a week or two and come back. I wish that was more symmetric, where people from wherever country you're in could find their way to the United States. I was just at the PyCon in Pittsburgh, PyCon 2000 in Pittsburgh, and the one thing they're really good at is PyCons around the world, and PyCons around the world. They got PyCon Nigeria, they got PyCon Ghana, and then what they do is they find the people in PyCon Ghana, and they get them to the United States somehow, and they go to the PyCon US, and it's like just a wonderful experience, right? And so what I don't understand, and maybe I need to line myself up with PyCon better. I just really felt great about PyCon. The PyCon conference, there's only a few things that were interesting at the PyCon conference that had to do with Python. Thing was interesting was people, right? Getting all these people together, and teachers talking to teachers at the PyCon conference. And so maybe PyCon might be the way that I can find a way to get people to come to the country. And maybe I'll get to know the PyCon people better and figure out how they get visas for people in Ghana to come to the United States, because that's not an easy thing. It's just not an easy thing. So there you go. Yeah. Okay, let's see what else. Jaden. The Argonaut. I took your Python course, now I'm taking your C course. Struggling but slowly moving forward. Yes, I hear that from a lot of people. Allow yourself to struggle and allow yourself to move forward, and feel free to go backwards a little bit. When I got done with it, I'm like, whoa, this is a lot of stuff, and I made a lot of assignments. And I've just gotten rid of a bunch of them, and you could go through faster. But I just feel like you're only going to, what's the song? You got one shot. Don't lose the moment in the, I think it's Eminem. I'm not very good at pop music, but what better time to learn data structures and algorithms and C and architecture than now? If you're gonna lose your patience and you're gonna rush through it now, what are you coming back to it later? When are you gonna do the hard work to really understand something? And the answer is, I say now, which means give yourself a break. Don't beat yourself up. Don't give yourself an arbitrary deadline, because that'll just make you grouchy. And don't tell yourself that you're not keeping up with the schedule that you put on yourself. Don't do that. You're either going to make it or you're not going to make it. And if you make it and don't retain it, then it was a waste of time. Humberto says, I hate SQL joins too. I don't hate them. I love them. But they seem scary to me because of the combinatoric stuff. Let's see. Have you looked into the Zig language? No. I didn't even know there was such a thing, so I haven't looked at it. Let's see. Oh, AI. Let's go back to Anna. I don't know if Anna's still here. Hi, Anna. Welcome to the channel. Anna said, talk about AI and programming. Love to. I've talked. I've talked in lots of places. When I went back to India, lose the thing. I've got people in the chat that are helping me with the Eminem lyrics of "Lose Yourself in the Moment." You never let it go. Da 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 da. Yeah, retaining is the hard part. And I know people that can't retain it. That's unfortunate. I retain it. Some people can, some people can't. So let's talk about AI for a bit. So when I was in India, I was there for over 2 weeks, and I went to like 9 universities. Hi, Anna. Welcome. Glad you're here. I went to 9 universities, and I gave talks to anywhere from 100 to 3,000 people. And as soon as we went to question and answer session, the AI question was the first or second question that I always got. So I was able to answer like, why program in the age of AI? And I would come up with all kind of answers. But by the end of the second to last presentation I gave was at a place called the Lovely Professional University in Amritsar, which is north. Before the talk, they were giving me a tour of the campus. And it's a beautiful campus. just a large campus, a lot of people. It's an agricultural school, and so there's beautiful fields. And so we were driving around and looking at all this stuff, and they took me to a student research area where they were researching drones. And so we hop off the car, I walk into this little student research lab where they're looking at drones, and I'm like, my first reaction was like, why are you showing me drone research? Like, I can go on Amazon and I can have a drone delivered tomorrow morning to my house, and I turn it on, it works perfectly. Beautiful video comes through, I can put goggles on and drive, and like, why are you researching drones? Drones are just a thing you search for on Amazon. And I asked them some questions about that, and they started talking about the kinds of things that they're still struggling with in drones. And it's like, oh, so drones aren't a solved problem. But then I came up with the following formulation. And that is, we think that AI is so creative, and we just assume that nothing in the future, we don't need to do anything in the future, that AI will do everything. And so I came up with this thought experiment. We now have wonderful AI software and wonderful AI hardware. So like there's these LLMs, there's the Llama LLM, and then there's the NVIDIA hardware. So let's do this. Let's take all the LLM software, stick it on like a USB stick, take a bunch of NVIDIA computers, and let's pack them into a luggage. Like we'll take 1 million NVIDIA computers and all the current LLM software and pack it into luggage. And let's go into a time travel device. We're us and NVIDIA and LLM software. And let's go back to 2000, 24 years ago. Set the time to go back 24 years ago. So I'm old enough to remember that in 2000, I would see really cool popular science articles or whatever, back when they had magazines, about the concept of these quadcopters and artificial intelligence and programming quadcopters and wireless and sending video wirelessly. And these people would be doing research. They had these big rooms that had these nets because the little, and they couldn't even be in the room with the things, because if you were in the room with the thing and the AI thing went wrong, it would come and cut you, right? Because this little quadcopter would turn on and go right towards you, and you'd get hurt. So you had to do them in these padded rooms with these nets to capture them, and then they would go up and crash and explode, and then they have to go build all new they'd build a quadcopter, take a couple weeks, build a quadcopter, stick it in a room, hit the go button, and it would smash into something right away. You know, and when you're watching that basic research on quadcopters, you're like, I'm going to bet that that's going to work out pretty cool soon. And then, you know, years later you go and the Super Bowl has little quadcopters with LED lights. They're flying around and they're talking to each other and they're animating stuff and making it look like a dragon. Like in the Chinese New Year, you see these dragons flying through the sky. That's nothing but quadcopters and lights. And you're like, wow, that's cool. But there was a time when the quadcopters could not be a dragon in the sky. As a matter of fact, you turn them on and they explode. Okay? There was a lot of work that needed to be done. So here we go. Back in 2000, quadcopters are not invented yet. People are imagining that they might be, right? Everyone imagined that they might be able to make a dragon fly through the sky, but they couldn't. They would have a quadcopter. It would turn on and blow up or cut a person if it was in the room. So now you come back into 2000 and you bring with you $500,000 worth of NVIDIAs and all the best software in the world, and you turn it on. Plug it in, plug the network in, and say, hey, LLM, go. Go. Figure it all out. Go to 2000. Figure all the human knowledge that's available in 2000. Read it. Understand it. It's kind of like Hitchhiker's Guide to the Galaxy, right? Where they created they created a computer to answer the question, right? The most important question of all. The answer to the life, universe, and everything. So think of that as NVIDIA and LLMs. You take it back in time, and you have it analyze everything it could possibly analyze. And after years and years and years and years, just like in Hitchhiker's Guide to the Galaxy, humanity gathers because the computer, the LLM in 2000, has analyzed everything. And we ask it one question. What is the answer to life, universe, and everything? Which, of course, is then 42. No, that's not the question we ask. Instead, we ask, could you build us a quadcopter? And the computer that's supposed to answer everything, that's come from the future with the best future software and the best future hardware, goes, what's a quadcopter? Right? So we got to not look at today's AI as answering the questions about, like, what's a way in React to have a clock? No, everyone knows that. I mean, sooner or later, that's a known thing, and all the LLM did was find it and reformat it for you. They do know languages, and that's really beautiful to watch them express things when given good prompts. They can synthesize past information into things that have never been seen before, like pictures, where the trees have roots that go up instead of going down, but it's really pretty and very abstract. And you're like, ooh, I like your crazy sense of humor in that picture you just drew. But there are things in this future that we're going to have to solve. And AI can't solve them. But guess who can solve them? Well-educated people can solve them. And AI can help those well-educated people as they make progress. And you could imagine if in 2000 they had AI and they started writing papers about quadcopters, and the AI could read the papers, and then someone else could, like, ask a question about AI, it would know the quadcopter research to date and maybe synthesize something and give them an idea without making them read all that crap. Because part of research is reading a bunch of crap. AI can read the crap for us, and it's helpful. Like, when you get a PhD, the first chapter is previous work. I'm not sure we need that anymore. AI is pretty good at previous work. And if we start thinking about producing results so that AI can understand them better, and now you're about to do some research in an unsolved problem and you want to see what the previous work was, and they've been writing for 20 years, we've been writing work so that we understand it's going to be searched and understood, it's going to be awesome. But it's not going to be able to take one step into the future. It's not. It can resynthesize and remix the past over and over and over again in extremely delightful and creative ways, no question. But it's our job to go into the future. And so that's what I think about AI. I think that with AI, we have no less responsibility than to teach ourselves the things that will help us understand AI. And what do I think you should learn so you understand AI better? Oh, Python, C, computer architecture, SQL. Those are the kinds of things that make it so you understand AI better. And people who know Python already understand AI better. So I am not threatened at all by AI. I do know that an AI version of me would look younger probably and have a better complexion. But that's also called a Instagram filter, So that didn't even need LLMs to make us look better if that's what we wanted. So, okay. Dr. Chuck, how do you suggest going through your courses? Last time I set my plan into this order: Python, then C, then Django, then Postgres, then Web. Yeah, I like that order. Python, then C. Although one of the things we're doing with Sean at the University of Michigan is he's doing research as to what the best path is. So the question I have right now, my hypothesis in that research, is it Python Django C or Python C Django, right? And just those three things. What I want to do is I want to look at, and C's not been around long enough to get us any good data, but when it has, the hypothesis that I have is that today, we foresee that students would take Python and then take Django and then quit halfway through Django because it just got too hard. Because Django is very abstract. It's very object-oriented. And so I just think that it might be the case that Python is not enough preparation for Django to really understand Django. So my hypothesis, which is just in research, you make hypotheses and then you check your hypothesis. My hypothesis is that taking the time to go through C and then learning Django with the understanding that you gain by learning C and object orientation is what you're really learning when you take the C class. I think that Django will be easy and better retained. But that's just a hypothesis. So, Omar, what do you mean? Unfortunately, most people don't understand your analogy. Do you mean the analogy of AI? Yeah. A lot of these programmers out here in the field are not creative. Yeah, I get it. I mean, programmers are only creative for small fractions of what they do. Most of the time, they're just like this morning. Before this started, I almost ran out of time and started late. I was trying to figure out how to send a damn email from Python. And I get this error message, and it was like I was beating the heck out of it, and like I got the code. It worked 6 months ago, and now it doesn't work. And the mail server keeps saying, you're violating a policy. I'm like, what policy am I violating? How can AI help me on this? Can't. I'm Googling. I find all kind of pages. Tells me all the things I already know, and no one can tell me what I don't know. And I'm just trying to send email from Python. It's that simple. And I've got a account, a password, and all that stuff. And it worked a few months ago, and now it doesn't work. AI help me. It can't. It's just too specific. Because it's some weird thing that some company did to their software sometime in the last 6 months that takes perfectly working code and makes it break. Now, I'll solve it. I'm just going to bang hard enough. I might have to call them, right? I might have to call the company, like, what's going on? Probably won't. I'll just switch companies. That's what I'll probably do. But again, is that creative? It's not very fun. It's just sometimes you bang your head on something long enough and just kind of something comes to you and then you make a breakthrough. And that's not what LLMs are doing. LLMs wander a network of what they consider truth, which isn't always truth, and tries to synthesize new expressions from that truth. And my problem I'm solving this morning is not like that. So, in terms of practicing C, I just say get through the course. There's a lot of homework in the course. I can see why people might want to practice Python or practice Django, but I don't think there's a lot of need because the learning objective is not become a great C programmer. The learning objective is to understand Python. Yeah, ChatGPT or even the Google one LLM is like you having a talking interactive Wikipedia, not the most efficient in logic and problem solving. Yes. Yep. Yeah, I agree. And they're just so impressive. And it's no different than Google search. I mean, I remember in 2008 talking about how Google search was so good that we gave it human-like characteristics. And the answer was Google search never had human-like characteristics. It just did what humans do better than what humans do. But it's not the most important things that humans do. Looking up, like the example I used, is let's just say that you had a vacation 2 years ago. And you and I were on vacation. And I'm like, do you remember that sunset where we had the dinner in Paris, where we were both having snails, and you didn't like the snails, but I did like the snails. But do you remember the color of that sunset? And if you and I were on vacation like that, your brain would be just going through data so fast while I'm talking, and somehow you would see a picture of that sunset from 5 years ago, right? And so, like, wow, that's a very human thing to be able to take all the images in the last 5 years and quickly come down to the one image that is that sunset while we were eating snails. And so Google seems to do that. You can say, Paris, sunset, eating snails, what color? And then up comes a picture. And you're like, dang, that's very human. And the answer is, humans do a lot more things than retain pictures and search the pictures. Even though we're good at that, we're good at visually recording our world and going back in time and finding things from our own internal visual recording of the world. Like I was talking to my flight instructor, and I hadn't seen him in like a year because I kind of took the winter off, and I'm like, do you remember that one time like where we were taking the crosswind turn and you told me to do a power off landing, from a downwind? And he goes, yeah. And he knew it. He knew what day it was. He knew what the temperature was that day. He knew what the sky conditions were like, because it turns out it's important when you do practice of power off things. It can't be too hot. The wind can't be too bad, because you got to do it safely, right? And again, how many seconds were happened in the last year, and he and I can both retrieve that concept, that image. And again, Google can do a lot of that, and YouTube can do a lot of that. I got a little exam so that I can go solo again, rent my own planes and go solo. And I mean, the last time I took the written exam was in the 1980s, and I studied, and I'm sitting in front of on my couch, I'm sitting on YouTube, I find a playlist, kind of like the classes I teach. I'm like, whoa, these guys are great teachers. I'm going to just chill and sit back and learn some stuff, and that's kind of fun. But it's not AI. Okay, where else we got? Kimberto, yeah. Sometimes it feels like other students are doing way more stuff than I am. That's FOMO, right? Fear of missing out. And I see this a lot in my on-campus classes, and it is a real frustration. FOMO is a real frustration. And so I teach a class, and I teach it to our majors who are not computer scientists. And I design the class for our majors who are not computer scientists, like the Django, like DJ Free. And I design it to be slow enough so that our students who don't have a computer science background can find their way through it and survive 15 weeks without having their heads explode. But then computer science students are allowed to take it as kind of like a technical elective, and the pace at which I teach it is, for them, the slowest technical class they will ever take, which means the stuff that takes 4 to 6 hours for a regular student takes 14 minutes for a computer scientist. And the kind of questions the computer scientist has are so different than the questions that my students have. And when a computer science asks a question, and the major students listen to it, they're like, I hate the world because I don't even understand the question you're asking. And so that's not because you're good or bad or whatever. That's just because you have a different lived life up to that moment. And so that's the key, is that don't worry if some students are just naturals. A lot of people who are taking the Python class already know Python, and they're just whipping through to get a certificate. If you go on the forums and you see them asking these really sophisticated questions, don't feel bad that those aren't your questions. They are not the audience of the course. You are the audience of the course. I'm going scrolling back. What's the future for C? We covered all those. We're running out of questions, folks. I'm running out of questions. I don't even know how many people we got. Let me Go to a different screen. I got 28 people still. That's nice. So I think I'm kind of caught up with the questions. Yeah, my goal is to make it so that people with patience can all make it, right? That's the key. Yeah. Okay. Well, let me wrap up a bit, and then we'll finish. So the thing we talked about this week was the epilogue, the plot twist at the end of C Programming for Everybody, where I finished the course and then realized I could ask Guido some questions. And if I asked Guido questions, I would ask him, like, how well did I do? And it's strange, it's a C course, but because I used Python examples, I thought I might have inadvertently built, like, I might have walked the path of Guido as it, but I didn't. Guido didn't use linked lists, even though Kernighan and Ritchie chapter 6 did use linked lists. And Guido has used a whole different way of doing dynamic memory allocations than most computers are taught. And I thought it was really delightful and a complete and total plot twist. And it's not in the Coursera class as of right now, May 24th, 2024. But it will be, by midsummer probably, because the stuff is already done, and you can see the. Let me put this in the chat. You can see the epilogue at www.cc4e.com under lessons. I think I typed epilogue correct. Okay. So the other thing is that you can subscribe to Dr. Chuck Plus, the place you're seeing this video, and then you'll know right away when I'm doing something live. I'm doing some live coding. I did a bunch of little reporting from PyCon. I'm trying to basically just give folks sort of a programming influencer, as it were. I realized that when I came back from India that I'm kind of becoming an influencer, and so I created this Dr. Chuck Plus, also known as plus.drchuck.com. I created this so that I could do influencer-like things without messing up my old YouTube channel. I mean, my old YouTube channel has 100,000 views, 100,000 subscribers. So, but that YouTube channel doesn't make any money, and I don't do silly things on it. I just put really cool educational content on it. Not a lot of live programming. So there's 100,000 people subscribed that really kind of want new lectures that are useful. Like all the lectures for the epilogue are sitting on the Dr. Chuck original channel, and Dr. Chuck Plus is the kind of more silly, sort of in the moment kind of thing. And we'll see where it goes. And so feel free to like and subscribe and do all those things. And here I am being an influencer. So with that, I will take my leave, and every few weeks we will. Oh wait, let's just see if this works yet. Let's see if it's charged up enough. Mm-hmm. I need to make it darker in here. So, the lesson that we have today, I got to turn this off now. Lesson we have today is the lesson we have today is that by the time you take a Java class from me, I want you to be able to wield object-oriented programming concepts like a lightsaber. Cheers all. See you next time.